Hello there, welcome back to the new lecture. So in this lecture we have to discuss toilet ventilation system part 2. So already I have discussed the part 1. Now here we have to discuss the calculation part. So after this lecture you would be able to understand calculation by air changes method. Okay, so we have a two method for toilet ventilation system. First is air changes method, so that we have to learn. After that we have to see the calculation, how to design toilet ventilation system by using ASHRAE method. Then I will show you the exhaust fan selection. Okay, thumb rule. I will show you the thumb rule for exhaust fan selection. Okay, so let's start. Now remember here, in case of toilet ventilation system, I have already discussed you that in toilet ventilation, for the designing of this ventilation system, we have two method. First air changes method and second ASHRAE method. So first of all I will discuss about air changes method. Okay, now see the calculation, how we can do the calculation with the help of air changes method. Okay, first method is what? Air changes method. So in that some formula is there. With the help of that formula only you will get all the calculation. Now I have told you that first of all we have to find out the exhaust air CFM, that how much amount of air we have to exhaust from the toilet. So that air, how you can find out? With the help of this formula. Exhaust air CFM is equal to volume of space in meter cube into ACH divided by 1.7. ACH is what here? Air changes per hour. Okay, and to calculate the fresh air CFM, because what happen when you are exhausting or when you are extracting air from the toilet, so the oxygen level inside the toilet will decrease. So to maintain the oxygen level or to improve the indoor air quality, we have to supply the fresh air also inside the toilet. So how much amount of fresh air we have to supply? So it is written, once you get the exhaust air CFM na, 70 to 80% of that exhaust air CFM is our fresh air. That much amount of fresh air we have to supply inside the toilet. Okay, now remember here, where ACH is air changes per hour, it means what? In 1 hour how many times you have to change the air to improve your indoor air quality. So from where you take this? So remember here, suppose if you are designing for public or commercial toilet, so on that time ACH value you have to take between 12 to 30. Okay, take average value 20, 22. Okay, for commercial toilet, remember. And if you are designing private or residential toilet, so for that ACH we have to take 6 to 10 times. It means in 1 hour we have to change how many times of air? 6 to 10 times we have to change the air in case of residential. Okay, and in commercial 12 to 30 times we have to change the air. Okay, now it can be easily, you can easily understand this concept when I take one numerical on that. See, now see the question here, what it is written. Suppose we have a toilet of length 5 meter, width 5 meter and height 3 meter. Okay, just here I am taking just example. Okay, suppose we have a toilet, the length of toilet is given 5 meter, width 5 meter and height 3 meter. Now what we have to find out? We have to find out the exhaust air CFM, fresh air CFM, exhaust duct size, fresh air duct size and disc valve size. Okay, because we have to place the disc valve in the ceiling level, so we have to find out the disc valve size. And it is telling design for private toilet. Suppose we are designing for private toilet. Okay, now see how to solve this question. So we know that what it is given, formula to find out the exhaust air CFM, volume of space in meter cube into ACH divided by 1.7. Okay, and what is given here in question? Length is given 5 meter, width of this toilet is 5 meter, height 3 meter. Now with the help of this length, width, height, we can easily get the volume in meter cube, and remember the unit also. Okay, we have to put the value in meter cube. Okay, so just calculate the volume of that space, and we know that volume of space is what? Length into width into height. so you will get 75 meter cube volume of space. Okay, now you can see here we are designing for private toilet, and so for private toilet I have already shown you we have to maintain ACH how much, 6 to 10, means in 1 hour we have to change the air how many times, 6 to 10 times. So see, suppose here, suppose I am assuming 8, okay, ACH I have taken average value 8 time we have to change the air. So we have to put this all value in the formula exhaust air CFM. So volume of space we have calculated 75 into 8 ACH value divided by 1.7. So finally we get how much CFM exhaust, 353 CFM air we have to exhaust from that toilet. Okay, so once you get the exhaust as CFM, so you can easily get the fresh air CFM. Now tell me what is the formula to find out the fresh air CFM. It is telling that 70, as per ASHRAE, telling that 70 to 85% of exhaust air CFM is our fresh air, and we have calculated exhaust air CFM 353. Now take the 80% of this, how much it will be. So finally you will get the fresh air CFM 282.4 CFM. Okay, it means that much of air we have to supply from outside to inside to maintain or to improve the indoor air quality. Okay, now see how to do the disc valve size. I have already shown you that some standard size of disc valve is available. Okay, 4-inch disc valve, 6-inch disc valve and 8-inch disc valve. With the help of 4-inch disc valve, how much air you can extract or you can exhaust, 15 to 100 CFM of air you have to, with the help of one disc valve you can extract that much amount of air flow rate. Now with the help of 6-inch of disc valve you can extract 100 to 180 maximum, 100 to 180 CFM from this space. And if you are using 8-inch dia disc valve, so with the help of that 180 to 240 maximum 240 CFM you can extract with the help of one disc valve. Okay, so here suppose I have selected two number of disc valve. Okay, see exhaust as CFM how much we get. Here I am talking about exhaust as CFM. Why I place this disc valve? For exhaust air CFM na, we have to exhaust with the help of this disc valve only. So total how much CFM is given, how much amount of air we have to exhaust from this space, 353, and I have selected suppose two nose disc valve. Okay, so each disc valve CFM is how much, if suppose I have selected two number of disc valves, so each disc valve CFM 353 divided by 2 you will get 176.5 CFM. And I told you, if you remember, now here you have to tell me that what dia of disc valve we have to select here and how many number of disc valve. So it depends on you. You can select the 4-inch disc valve also. If you have selected 4-inch disc valve, so it means you have to select two number of 4-inch disc valve here, because here see each disc valve CFM is given 176.5, and with the help of 4-inch disc valve you can exhaust maximum 100 CFM. So here you have to select the two number of 4-inch disc valve, or otherwise if you want to select the 8-inch, so with the help of one disc valve you can extract that much amount of CFM. Okay, so suppose here I have selected 6-inch disc valve. Okay, we take disc valve 6-inch. So if I am using 6-inch disc valve, so how many number of disc valve we need? One number, because with the help of 6-inch disc valve we can exhaust how many, maximum how many amount of air we can exhaust, 180 na, up to. So one number of disc valve you can select, 6-inch disc valve I have selected. Okay, now same thing, suppose if you want to do the grill size, for what purpose? Suppose indoor you want to place the grill for supply fresh air, okay, to intake fresh air from outside to inside toilet. So how to do the grill size? We have a formula, Q is equal to A into V. Okay, with the help of this formula we can easily get the size. So now tell me, if you remember, as per ASHRAE, what velocity, standard velocity we have to take for grill size? 500 fpm. Okay, and Q value, this flow rate value we have calculated. How much? Because we are placing grill for what purpose? For taking fresh air, na? So we have to take Q value, this 282.4, and velocity we have to maintain 500. So all value you have to put in this equation. Velocity 500 fpm, Q 282.4 cfm. Now when you put this value in that equation, so you will get the area 0.56 square feet. So grill area you will get. Now here, which shape of grill you want? If you want to place rectangular shape of grill, so on that time we know that area of rectangle is what? Width into height is equal to 0.56. Now suppose here, let I have assuming a height as a 0.4 feet, because this height will given by manufacturer only. Okay, they will provide you that much of height grill I have available, because we don't know na that how much height of grill manufacturer have they have manufactured. So that is why this detail will given by the manufacturer only. Suppose they will give you a 0.4 feet height grill. So based on that height you will calculate the width and send all this detail to the manufacturer that I want that much height and that much width of grill. Okay, so in this way you have to calculate the size of grill. Okay, width is how much in mm? 426.7 mm. Now see, area we have calculated for exhaust. Suppose I want to do the exhaust air duct size. Okay, so first of all we need the area na? So area, to calculate the area we have a formula Q upon V, and exhaust air CFM we have calculated 353 divided by V, velocity 800 I have taken here. If you remember, I have already discussed about that. I think for residential or for private building, if you are designing for residential building, so how much velocity we have to maintain inside the duct? 700 to 900 fpm. Okay, so here I have taken 800. So when you calculate you will get the area 0.44 square feet. Now suppose if you are doing this size, if you are doing this size for a rectangular duct, okay, if you have selected rectangular duct, so for that area we have calculated 0.44 square feet, and we know that area of rectangle is what? Width into height. It is shown in figure. See, suppose if you are look front view of your rectangular duct, so what is visible? Width and height. So area is what? Width into height. Now here we have to follow the aspect ratio as per SMACNA. I have told you what are that. Always when you take the ratio of width and height, always this ratio will always greater and equal to 1 or less and equal to 4. As per SMACNA we have to satisfy this ratio. If you here height we have to assume. Okay, suppose if you have assumed any height, if you have taken any height, and just take the ratio width upon height, and if you get the value between this 1:4 ratio, if your value is coming between 1:4 ratio, so it means your size is correct, the size which you have taken it is correct. If your value is not coming between this range, it means your duct size is not correct, because we have to follow this ratio. Okay, so now here suppose I am assuming let height of duct is 0.4 feet. Okay, now you have to put this value in that equation. Finally you will get the width of that duct 1.1 feet. So you can convert that feet into mm. Okay, so when you convert now, so width you will get around 350 mm, and height of duct is how much? 150 mm. Now just divide both of them, high size divided by low size, 350 divided by 150, you will get around value how much? 2 point something. It means your ratio is coming, aspect ratio is coming between this range now 1 to 4 na? So it means your size is correct. Okay, So exhaust at duct size is how much we have calculated, 350 mm width and 150 mm height. Okay, but remember this condition we have to follow only for rectangular duct. Suppose if you have selected round duct, okay, if you want to install the round duct, so on that time we need the diameter of that duct. So how to calculate the diameter? If you know the area, and area we have calculated 0.44 square feet, so easily you will get the diameter, because we know that area of circle is what, pi by 4 d square, and you can just simplify that and easily get the diameter, how much in mm, 250 mm diameter of duct we need. Okay, so this is for round duct. Correct, everyone? Now suppose if you have selected a square duct. Okay, so for that what you have to do, we know that square, all sides are equal for square. Okay, so here I have taken side, let's a, small a. Okay, and we know that for a square all sides are equal. So area, it is we have calculated 0.44 square feet. Now the area of a square is what, a square, so finally you will get the value of a, 200 mm. Okay, so in this way we have calculated the exhausted duct size, how much, 200 mm into 200 mm for square duct. Okay, and same thing if you want to calculate the size of fresh air duct, so again you have to calculate the first area of that duct, because q value, airflow rate value is different na? So we have to again calculate the area. Okay, so now see the fresh air duct size. Formula is same, q is equal to av, but here v velocity we have to take, okay, same 700 to 900 fpm, but q value we have to take 282.4 cfm, which we have calculated 80% of exhaust air duct na. Put all this value, so you will get the area finally. Suppose if you have selected, if you are doing the sizing of rectangular duct, so on that time first we need the area, so when we calculate na, you will get around 0.353 square feet, and we know that area of rectangular is what, width into height. Here height you have to assume, and you have to follow this ratio. If your value is coming, this aspect ratio value is coming between 1 to 4, it means your duct size is correct. Okay, now suppose here I am assuming, let height is equal to 0.3 feet. Put the value, you will get the width. Okay, finally you can convert this feet into mm. How you can convert? We have to multiply by this factor, 304.8. so width we have calculated 350 mm, height of duct 100 mm. Okay, finally we get the fresh air duct size 350 mm into 100 mm. Okay, and note here, similar we have to do for round and square duct size. Okay, okay, so now here what we have done, the calculation by air changes method. Okay, that is first method. Now here see how to design the toilet ventilation system with the help of second method, ASHRAE method. Okay, so in that also we have to remember some points while designing with the help of ASHRAE method. So what it is telling, according to ASHRAE, ASHRAE is what, American Society of Heating, Refrigeration, Air Conditioning Engineer. Okay, so what it is telling, see, suppose if you are designing for public toilet, so it is telling for public toilet we have to extract 50 to 70 cfm per unit. Means from each toilet how many amount of air we have to exhaust, 50 to 70 cfm. When we have to take the 50 cfm, when we have to take the 70 cfm, remember, if your fan is running continuously, on that time the fan which you have installed inside the duct na, inline fan, if your fan is running continuously, okay, so on that time you have to take 50 cfm, mean from each toilet you have to exhaust 50 cfm of air. Okay, if your fan is not running continuously, so on that time you have to take 70 cfm for per unit. Okay, for per toilet, for each toilet we have to take we have to exhaust 70 cfm of air. Okay, now for private, 25 to 50 cfm per unit, means for each toilet, for if you are designing for private, from each toilet we have to exhaust 25 to 50 cfm. So same concept is same. If your fan is running continuously, so on that time you have to take 25 cfm you have to exhaust, and if your fan is not running continuously, so on that time you have to take 50 cfm for each toilet. Okay, remember. Now suppose if you are designing for commercial toilet, so in that generally we have a passage area also, for cell with toilet or passage areas, both are similar. Okay, sometime you see for cell with toilet is also called as a passage area. So for passage area, okay, we know that from toilet, if it is a commercial, so we have to exhaust, for each toilet we have to exhaust 50 cfm. But for passage area, what we are doing, what we have to do, so it is based on your how much square feet of area is there. Suppose if your passage area is 200 square feet, you have to measure with the help of a command in AutoCAD file. You have to measure it. Okay, dimension linear command you have to use and measure, or we have a list command also. Okay, you will get the area, passage area. So remember, for passage area, for 1 square feet area, how much cfm we have to exhaust? 1 cfm. Suppose it is coming 200 square feet area, passage area is coming 200 square feet area, it means we have to exhaust 200 cfm from the passage area. Okay, so in this way we have to do the calculation. Now how to calculate the fresh air? Same thing, 70 to 85% of exhaust air cfm is our fresh air cfm. Suppose uh, suppose if you have 10 number of toilets, public toilet, okay, you are designing for public toilet, so it means from each toilet, suppose I am exhausting 50 cfm, 15 to 10, how much? 500 cfm, total exhaust air cfm 500 cfm. So you have to take 70 or 80% of that 500 cfm, you have to supply the fresh air. Okay, so in this way we have to do the calculation with the help of ASHRAE method. Now before taking any numerical on ASHRAE method, see here, first of all we have to remember this conversion formula. It is very important. Okay, that 1 meter cube per second is equal to how many cfm? 2118 cfm. Okay, meter cube per second is our metric unit, and cfm, cubic feet per minute, is imperial unit. Okay, if you want to convert metric to imperial, so you have to follow this formula. And 1 liter per second is equal to how many cfm? 2.11 cfm. Correct. Now the third conversion is 1 cfm, means 1 cubic feet per minute, is equal to how many cmh, cubic meter per hour. So 1 cubic feet per minute is equal to 1.7 cubic meter per hour. Okay, remember this formula is very important. Now the next is 1 cmh is equal to how many cfm? 0.58 cfm. Okay, and 1 inch of water gauge is equal to 248.84 pascal, or 1 mm of water gauge is equal to 9.797 pascal. Okay, so just all of you try to memorize all this conversion, it is very important. Now see how to do the exhaust fan selection. So remember, fan selection is based on what? Here we have two methods for selection of exhaust fan. First, volume of airflow. We have to calculate the volume of airflow in cmh, cubic meter per hour. When you calculate this airflow in this unit now, so with the help of catalog you will get all the model of that fan and size, throw value, all this thing you will get. Okay, this is our first method for the selection of exhaust fan. Second method is what? Static pressure. We have to calculate the static pressure. Okay, okay, so now see, first I have told you, first method is what? Volume of airflow. We have to calculate the volume of airflow. So how to calculate? Formula is same. Here remember I am talking about ASHRAE method. If you remember, I have told you, so suppose if you are designing for public toilet or for commercial toilet, so from one toilet how much amount of air we have to take? We have to exhaust 50 cfm. if your fan is running continuously on that time. Okay, 50 CFM we have to exhaust. Okay, so suppose it is a 10 toilet, so you will get the total exhausted CFM. Okay, so once you get the value, airflow rate value in CFM, so you have to convert that CFM into CMH. Then only with the help of catalog, because in catalog airflow value is given in CMH only. Okay, that is why I am telling you have to convert first of all. So you will get the all model number of that fan, throw, noise level, everything they will provide you. Now the second is static pressure method. Okay, so in that static pressure we have to calculate here to be considered for the longest ducting routing. Suppose if your duct route is long, okay, so you have to follow this static pressure. So how to calculate? Suppose it is written for 1 meter of straight duct we have to take how much value? 0.04 inch of water gauge, or less than that. Okay, how much we have to take? 0. For 1 meter of straight duct, static pressure is 0.04 inch of water gauge. And suppose if any 90-degree elbow is coming, okay, if in your duct routing 90-degree elbow is coming, so for that we have to take 0.2 inch of water gauge. Okay, for 45-degree elbow we have to take 0.1 inch of water gauge. Suppose if shoe neck is also there, suppose if when you are giving the branch duct from main duct, so we have to install the shoe neck also. We have to make the shoe piece. So for that, remember, shoe neck is considered as a 90-degree elbow. For that, how much static pressure we have to take? Static loss 0.2 inch of water gauge only. Okay, now see here, I take one question here so you can easily understand what it is telling. Commercial toilet having 10 units with a passage area of 250 square feet. Okay, find the CFM and fan capacity. So how to calculate for that? See, suppose here what they are told you that we have a 10 number of toilet and passage area is also there. You can see in this image here we have a 10 number of toilet and passage area is given. Okay, how much area? 250 square feet. Now it is telling find the CFM and fan capacity. So how to find out the exhaust air CFM? If you remember, I have told you that this is suppose commercial toilet na? So for commercial toilet, for each toilet how much air we have to exhaust? 50 CFM to 70 CFM. Suppose here I am assuming my fan is running continuously, so on that time we have to take 50 CFM for each toilet. So from each toilet how many air we have to exhaust? 50 CFM air we have to exhaust. So it is written here each toilet exhaust air CFM is 50. Number of toilet is given 10, so total exhaust air CFM how much? 50 into 10, 500 CFM we have to exhaust. But from the toilet here passage area is also given 250 square feet. I have told you for passage area 1 how many air we have to exhaust. For that ASHRAE is given that 1 for 1 square feet area we have to exhaust 1 CFM. So for 250 how much we have to exhaust? So cell with toilet is given or passage area is given 250 square feet. So therefore exhaust as CFM we have to exhaust 250 CFM. So add both of them, total which you have calculated now for toilet and for cell with toilet. So total exhaust as CFM is how much? 500 plus 250, 750 CFM of air we have to exhaust from this commercial toilet. Okay. Now to calculate the fresh air CFM, I have told you that 70 to 85% of exhaust air CFM is our fresh air CFM. If you want total, you have to do total. Otherwise, suppose from each toilet exhaust air CFM is given 50 CFM and I want to give the fresh air for each and every toilet. So how to calculate? 70-80% of this 50 CFM is how much? You have to calculate, so you will get finally 40 CFM. It means for each and every toilet we have to supply how much fresh air? 40 CFM fresh air we have to supply for each and every toilet. Okay, to improve the indoor air quality. Now if you want to calculate the cell with toilet, how much we have to supply the fresh air in passage area? So we have calculated, if you remember, exhaust air CFM in cell with toilet is how much? 250. So 80% of 250 we get 200 CFM. Now if I told you total fresh air CFM is how much, we have calculated 600 CFM. That much of air we have to supply from outside to inside. Okay, and how much air we have to exhaust? 750 CFM total, and total fresh air CFM we have to supply inside the toilet, how much? 600 CFM. Okay, now you can see here, first, volume of airflow. So exhaust air CFM we have calculated total 750 CFM. Okay, so to find out the fan capacity, I have told you first method is volume of airflow. So we have once you get the CFM na, you have to convert that CFM into CMH. So how to convert? In conversion formula is given 1 CFM is equal to 1.7 CMH. So you will get the value in CMH. Okay, so finally with the help of catalog you can easily find out the model of that fan, throw value, all these things. Now second, we have a static pressure. Suppose and I have told you that always this method we have to use always if your duct routine is long. Okay, for longest duct route we have to use static pressure. So suppose here I have taken one drawing. Okay, suppose we have drawn this all toilet exhaust system, 10 number of toilet is there, and this red color duct is what? Exhaust air duct, and green color duct is supply fresh air supply duct. Okay, so we have placed, see, in each and every toilet we have placed disc valve here. Okay, through that disc valve we have connected flexible duct and then branch duct. In branch, before connected to main duct, we have to place the shoe neck, we have to give the shoe piece. Okay, then only we have to connect branch duct to main duct. Okay, all air we have taken for each and every toilet, and from passage area also, see, we have installed the disc wall in passage area, and we are taking all the air to the outside to the roof. Okay, so with the help of that roof we have to install the fan also inside that duct, inline fan, and you can extract that air outside. Okay, so here remember, always we have to take the longest duct route, don't take this branch. So longest duct route is what? If you are suppose find out the capacity of exhaust air fan, so this is our longest duct route na, because this is the last toilet, this branch duct and total main duct. Eliminate this all branch duct, okay, which is coming between them. So when I draw the single line, it's look like this. See, this is our riser which is going up, 20-meter length of that duct is there, and this horizontal duct length is 15 meter, and here we have one shoe neck and branch duct which we have we are connected to this disc wall. Length of that duct is 5 meter. Now see how to calculate the. So now here you can see I have drawn one single line diagram of our duct, longest duct routine. You can see this is our main duct and this is the last branch which we have taken, because always for we have to take the longest duct routine, okay, for the fan selection. So here one fitting is also coming, shoe neck, that I have taken here. Then branch duct length is 5 meter, main duct length is 15 meter, and the duct is going up into the terrace because we have to place the fan in the terrace. So forcefully we can exhaust that bad odor from the toilet space. Okay, so vertical duct length is given 20 meter. So here also we get one fitting 90-degree elbow also we need. Okay, so let's see. So for straight duct, what we have to do? First you have to count out the total straight duct, 15 meter, 5 meter plus 20 meter. So we know that, see here, we know that the total length is 40 meter. See, 15 plus 5, and for 1 meter straight duct, how much static we have to take? Static pressure 0.04. So here we have a total 40 meters, so 40 into 0.04, so we get 1.6 inch of water gauge. Okay, Now same way, here one fitting is also coming, shoe neck. So for shoe neck, as I told you, shoe neck is considered as a 90-degree elbow. So for 90-degree elbow, we have to take the static pressure 0.2 inch of water gauge. So just multiply, only one fitting is there. So here we get 0.2 inch of water gauge. 190-degree elbow is also coming. So just take that. So finally, total static pressure, we have got 2 inch of water gauge. Okay, once you will get this static pressure, you have to submit this detail to the manufacturer. So they will give you the fan. So from the manufacturer catalog, as per this detail, you will get the model number of that fan, whatever you want. Okay, but here the formula is also available to find out the capacity. See, to find out the fan capacity in bhp, here we have a formula q, total exhaust flow rate in cfm, into specific gravity of air, plus into total static pressure which we have calculated, divide by 6356 into efficiency. So just here I have written the exhaust air CFM value 750, into specific gravity of air is 1, and total static pressure we have calculated in inch of water gauge 2. Then the factor, you have to write down the conversion factor, and efficiency I have taken here 80%. So as per that, how much capacity we have got? 0.3 HP. Okay, so near about 0.5 HP. So in this way we have to, by using the thumb rule, you can easily find out the capacity of exhaust fan. So if this video is important for you, so please do not forget to subscribe, like, and share my video to your friends, and do not forget to hit the bell icon so you will get the notification of my updated video related to MEP designing and modeling. I hope all of you enjoy this session. See you in next one.